चैप्टर हमें डिज़ाइन करना है यूनिक आईडी जनरेटर इन डिस्ट्रीब्यूटेड सिस्टम्स। बेसिकली हमारे पास एक डिस्ट्रीब्यूटेड सिस्टम है। जैसे कि पता है डिस्ट्रीब्यूटेड सिस्टम इज नॉट ओनली अ सिंगल सिस्टम। उसमें we distribute the data across multiple data centers। तो फिर वहाँ से हम फेच करते हैं अकॉर्डिंग टू द नीड्स। तो एक डिस्ट्रीब्यूटेड सिस्टम में वी हैव टू जनरेट यूनिक आईडी। तो इसका सिस्टम डिज़ाइन कैसे होगा? लेट्स स्टडी अबाउट इट। So in this chapter, you are asked to design a unique ID generator in distributed systems. The first thought might be a primary key with auto-increment attribute in a traditional database. However, auto-increment does not work in a distributed environment because a single database server is not large enough and generating unique IDs across multiple databases with minimal delay is challenging. Here are a few examples of unique IDs. These are the examples. Step 1. Understand the problem and design and establish design. Asking clarification questions is the first step. Basically होता क्या है? Why can't we use auto increment in this way? Well, we know that SQL में command होता है auto increment, in which we can just increment IDs according to the different rows, and हम ऐसे unique IDs generate कर सकते हैं. But distributed databases में ये why do we make distributed database? First of all, हम इसलिए करते हैं क्योंकि एक database is not large enough to store a lot of data. So we distribute the data across different databases. So this is not a distributed database. So auto increment function can work very well ऐसे scenario में, but ऐसे scenario जिसमें information distributed है, incrementing these IDs with minimal delay across different servers. जैसे यहाँ पे 1 2 3 4 5 हो गया, यहाँ पे 5 6 7 8 9 10, इधर से इधर इसको जनरेट करने में there will be some delay. So minimal delay के साथ इनको करना is very hard. So that is why we can't do this. So there are some steps to understand and establish the design. First step, understand the problem and establish design scope. So asking clarification question is the first step to tackle any system design interview problem. Here is an example of candidate interview interaction. What are the characteristics of unique IDs? Unique ID must be unique and sortable. For each new word, does ID increment by 1? For each new record, the ID increments by time but not necessarily only increments by 1. IDs created in the evening are larger than those created in the morning and on the same day. Do IDs only contain numerical values? Yes, that is correct. What is the ID length requirement? ID should fit into 64 bit. Which is the scale of the system? The system should be able to generate 10,000 IDs per second. Above are some sample questions you can ask the interviewer. It is important to understand the requirements and clarify ambiguities. For this interview question, the requirements are listed as follows. The IDs, जो अभी IDs हैं, they must be unique, they must be sortable, they they increment by time and not by one necessarily. IDs जो इवनिंग में जनरेट होंगी वो मॉर्निंग वाली से ज़्यादा वैल्यू की होंगी, and IDs will only contain the numerical values. IDs will fit into 64 bits. They are ordered by date. Obviously, ability to generate over 10,000 unique ID records per second. So we should be able to generate 10,000 unique IDs per second. Suppose high-level design and get a buy-in. Multiple options can be used to generate unique IDs in distributed systems. The options we consider are multi-master replication, universal unique identifier, ticket server, and Twitter Snowflake approach. Let's look at each of them and how they work. Multi-master replication. As shown in figure 7.2, the first approach is a multi-master replication. This approach uses the database's auto-increment feature. Instead of increasing the next ID by 1, we increase it by k, where k is the number of database servers in each. As illustrated in the figure, next ID to be generated is equal to the previous ID in the same server plus 2. This solves some scalability issues because ID can scale with the number of database servers. However, this strategy has major drawbacks. Hard to scale when multiple data centers. IDs do not give up time across multiple servers. IDs do not go up with time. It does not scale well when a server is added or removed. So basically हम क्या कर सकते हैं? पहला जो है हमारे पास ऑप्शन, that is multi-master replication. So multi-master replication is the first option. एंड मल्टीकास्टर एप्लीकेशन में होता क्या है बेसिकली, whatever we have a master database और डिफरेंट जितने भी databases हैं वगैरह, let's just say like we have 4 databases, so we will start like this and then we increment by k. So k is the number of databases, so यहाँ पे 4 है तो ये हो जाएगा 5 and this will be 6 and this will be 7 and this will be 8, ऐसे कर करके this will be 9 and this will be 10, this will be 11 and this will be 12. So ऐसे करके we can assign data some unique value, but इसके कुछ major drawbacks हैं. First thing is scaling issue. It is very hard to scale. It is very hard to use this theorem when database is being scaled, when servers are added and unique. And एक और है कि मल्टीपल डेटा सेंटर के साथ स्केल नहीं हो सकता and does not scale well when servers are added anymore and IDs do not go up with time. तो इसमें as we have a requirement कि IDs should go up with time. Evening में जो ID है वो should be greater than morning में ID. So but ऐसा इसमें कुछ हो नहीं रहा है. They are just assigning IDs based on the number of servers with an increment of k servers. Where k is the number of servers. तो इसमें ऐसा कुछ कंसिडर ही नहीं हो रहा, बस न्यूमेरिकल वैल्यूज असाइन हो रही है, वो भी माइस्क्यूएल के ऑटो इंक्रीमेंट फीचर से. सो ये था पहला मास्टर मल्टी मास्टर एप्लीकेशन. UUID. A UUID is another easy way to obtain unique IDs. UUID is a 128-bit number used to identify information in computer systems. UUID has very low probability of collision. Coding Wikipedia, after generating 1 billion UUIDs every second, approximately 100 years, would the probability of creating a single duplicate reach 50%. Here is an example. UUID is like this. UUIDs can be generated independently without coordination between servers. Figure 7.13, figure 7.3 of the we have a web server, we can generate a unique UUID. In this design, each web server contains an ID generator, and a web server is responsible for generating IDs. Both generating a UUID is simple, no coordination between servers is needed, so there will be not any synchronization issues. The system is easy to scale because each web server is responsible for generating IDs they consume. ID generator can easily scale with different servers. Cons है, IDs are 128-bit long, but our requirement is 64-bit. And IDs do not go up with time. IDs would be non-numeric. Yes. So second way है UUID. So UUID is basically an ID of the form which is 128 bits and it contains numerical and alphanumeric values basically. So UUIDs are generated and they are very server specific. एक सर्वर के पास अपना खुद का UUID जनरेटर होगा. सो इसका प्रोन हो गया है, प्रोज हो गया कि जब हर सर्वर के पास अपना खुद का आईडी जनरेटर है, देन इफ वी स्केल दिस ऑन आवर न्यू सर्वर और रिमोट सर्वर्स, तो हमें कुछ आईडी जनरेटर के बारे में ध्यान नहीं रखना पड़ेगा. बट इसके कौन से लाइक आईडीज आर 128 बिट लॉन्ग एंड रिक्वायरमेंट इज 64 बिट. आईडीज डू नॉट गो अप विद टाइम. आईडीज कुड बी नॉन न्यूमेरिक. थर्ड, we have ticket servers. Ticket servers are another interesting way to generate unique IDs. Because developed with ticket servers to generate distributed primary keys, it is worth mentioning how the system works. So we have different web servers and they are connected to a ticket server. Idea is to use centralized auto increment feature in a single database server, ticket server. To learn more about this, refer to Flipper's engineering blog article. Pros, numeric IDs, it is easy to implement and works for small to medium scale applications. Single point of failure, इसका कौन है obviously. Single ticket server means if the ticket server goes down, all the system depend on it will face issues. To avoid a single point of failure, we can set up multiple ticket server. However, this will introduce new challenges such as data synchronization. So we have another technique which is known as ticket server. We have multiple web servers and we have a centralized auto increment feature which is being by implemented by a ticket server. तो बहुत सारे सर्वर हैं और एक सेंट्रलाइज टिकट सर्वर है जो इम्प्लीमेंट कर रहा है ऑटो इंक्रीमेंट फीचर. उसका प्रोन है कि obviously values are numeric, values are 64 bit and there is no delay for syncing the values, right? Data synchronization का कोई issue नहीं है, it is easy to implement and for small to medium. इसका कौन है major कौन? Obviously, with any server, when there is a single point of importance, there is a as single point of failure SPOF. क्योंकि अगर ये ticket server खराब हो गया किसी वजह से तो like they can't have their ID generated और सब बिगड़ जाएगा, पूरा डिजाइन खराब हो जाएगा। तो इसके लिए we can have multiple ticket server पर इनकी data synchronization का issue आ जाएगा, वही बात आ जाएगी कि how do we synchronize auto increment for different servers. So last approach that we have, Twitter Snowflake approach. Approaches mentioned above give us some ideas, but about give us some ideas about how different ID generator system work. However, none of them meet our specific requirements, thus we need another approach. Twitter's unique ID generation system called Snowflake is inspiring and can satisfy our requirements. Divide and conquer is our friend. Instead of generating an ID directly, we divide an ID into different sections, which shows the layout of a 64 bit. So we have a 0 bit, we have a 1 bit, we have 41 bits for timestamp, we have 5 bits for data center ID, 5 bits for machine ID, and 12 bits for sequence number. Each section is explained with sign bit. 1 bit, it will always be 0. This is reserved for future uses. It can potentially used to distinguish between signed and unsigned numbers. Timestamp 41 bits, milliseconds since the epoch or custom epoch. We use Twitter Snowflake default epoch on 12 888 349 74657, equivalent to November 4, 2010. Time is 1 time is 1 a.m. 42 minutes and 54 seconds universal time. Okay. Data center ID 5 bits, which gives us 2 to the power 5 L2 data centers. Machine ID same, and sequence number 12 bits for every ID generated on that machine process. The sequence number is incremented by 1. Okay. The number is equal to 0 every millisecond. Okay, so this is a new approach. इसमें हमारा क्या है? Basically, Twitter Snowflake is something like हमारे पास 64 bits को we have divided. So we have a 0 bit here. We have 41 bits for timestamp. This is sign unsigned, and this is timestamp. And then we have 5 bits for data center ID, 5 bits for machine ID, and 12 bits for sequence number. So we have a data center ID, machine ID, sequence number, and a timestamp. This is a Snowflake cycle. Let's do a design deep dive. In the high-level design, we discovered various options to design a unique ID generator in distributed systems. We settle on an approach that is based on Twitter's Snowflake ID generator. Let us give Let us dive deep into the design. To refresh our memory, the design diagram is listed below. Data center IDs and machine IDs are chosen at the startup time, fixed once the system is up running. Any changes in the data center IDs and machine IDs require careful review since an accidental change in those values can lead to ID conflicts. Timestamp and sequence numbers are generated when the ID generator is running. Timestamp. The most important 41 bits make up the timestamp section. As timestamps grow with time, IDs are sortable by time. Figure 7.7 shows an example of how binary representation is converted to UTC. We can also convert UTC back to binary representation using a similar method. So first of all, we convert these 41 bits into a decimal value, and then we add a Twitter epoch, and then we convert millisecond to UTC. So we have a by default Twitter epoch, 1 2 8 3 4 9 something, 3 4 9 7 4 6 5 7, 3 4 9 7 4 6 5 7. तो फर्स्ट ऑफ ऑल भी कन्वर्ट दीज 41 बिट वैल्यू, इसको हम कन्वर्ट करेंगे एक डेसिमल नंबर में। जब ये डेसिमल नंबर में कन्वर्ट हो जाएगी, वी विल ऐड अ ट्विटर इपॉक वैल्यू विच इज इक्वल टू 128 डबल एट 349 746 and 57. So whatever value we'll have, we'll convert this into milliseconds. Milliseconds में convert करने के लिए obviously we'll divide it by 6 10 to the power 6, और फिर जो रिमाइंडर आएगा उसको सेकंड में वगैरह. So we'll have this date. The maximum timestamp can be represented by 41 bits at 2 to the power 41 minus 1, which is this number of milliseconds. which gives us 69 years equals this milliseconds divided by this seconds divided by 365 days divided by this. This means the ID generator will work for 69 years and have a custom epoch time close to today's date, delays the overflow time. After 69 years, we'll need a new epoch time or adopt other techniques to migrate IDs. Sequence number is 12 bits, which gives us 2 to the power 12 4096 combination. This field is 0 unless more than one ID is generated in a millisecond on the server. In theory, a machine can support a maximum of 4096 new ID per millisecond. Wrap up. In this chapter, हमने डिस्कस करा different approaches to design a unique ID generator, multi-master replication करी एक approach, GUID वाली, ticket server वाली, and last में Twitter Snowflake like unique ID generator. We settle on Snowflake क्योंकि वो हमारे सारी requirements को support कर रहा है and it is scalable in a distributed environment. If there is extra time at the end of the interview, here are few additional talking points. Clock, clock synchronization. In our design, we assume ID generation server and the same clock. This assumption might not be true when a server is running on multiple cores. Same challenge exists in multiple machine scenarios. Solution to clock synchronization are out of scope of this book. However, it is important to understand the problem itself. Network time protocol is the most popular solution to clock synchronization. Section length tuning. For example, few sequence numbers but more timestamp bits are effective for low concurrency and long-term application. High availability. Since an early generator is a mission-critical system, it must be highly available. Congratulations. Yeah. And these are some reference materials which you can refer to in this book. And yeah, that's it. So, आज हमने करा आज we did design a unique ID generator from distributed systems. So सिंगल सिस्टम के लिए इजी होता है ऑब्वियसली आज हमने पढ़ा डिस्ट्रीब्यूटेड सिस्टम में कैसे कर सकते हैं सो यस यही सब था एंड थैंक यू